Welcome back. This tutorial video is about finding bending stresses occur on the beam. I will have my beam, such a cantilever beam, and I will subject this beam to a moment of, let's say, I'm just going to put at 50 kilonewton meter. So the question asks, what is the stress at 2 points, point A and also at point B, somewhere here, and you will know the location from the cross section that I'm going to put later on. So the beam here is, if you take the cross section, something like this. It is a hollow section, and my diameter of, the dimension is 20 mm here, and it's all around. It's also 20 here. And this is 80 mm, and right here is 40 mm. My A is actually somewhere here. That's my A, and my B is actually here. Now, the first order of the day is to find out what is the moment of inertia, because we know, in order to get the bending stress for this type of problem, with bending stress, is the moment times C over I, and C here is actually the distance from the your center, and and I have my, this is the distance C for A, and this is actually the distance C for B. So that's pretty much C, okay? And we need to find out what is the I. So I for this type of shape is given as 112 times BH cubed. Now, since this particular material is actually hollow, so you need to only find out what is the moment of inertia of the materials. So what you can do now is you take the I of the material is going to be I of the outside minus the moment of inertia of the hollow section. So my moment of inertia of the outside is actually 112 times my B, which is 80 plus 20 plus 20, that's going to be 100. sorry, that's my B is actually 40 plus 20 plus 20, and my H is gonna be 80 plus 20 plus another 20, and cube that. So your outside moment of inertia is 112 times 80, and 120 cube. That will give you my I on the outside is 11.5 times 10 to minus 6, and the unit is meter to the fourth. My the hollow section is also 112 dH cube, but I will have different dimension. So my B is actually 440, and my H is actually 80 cube, and I will have my I for the cutout, which is the hollow section, is going to be 1.7 times 10 to minus 6, and so my I moment of inertia for that particular section is actually 11.5 times 10 to the minus 6 meter to the fourth minus 1.7 times 10 to minus 6. So my I for that particular section is it's too late. Okay, it's 11.5, 1.7. It's going to be 9.8 times 10 to minus 6 meter to the fourth. You always carry the units here. Okay, so this I for the section. So once I know the I can go ahead and use this equation here. My bending stress is MC over I, and for point A, I have my my A here is actually 40. Is actually 40 mm, and my B here is 60 mm. So let's go ahead and do that. So my sigma A is my moment, which is it's 50 kilonewton. So it's 50 kilonewton meter, and that is my M. And my C for A is 40 mm, and my I is 9.8 times 10 to the minus 6 meter to the fourth, and that will give you my A as 61.6 megapascal. Similarly, for the stress at point B, I will have 50 kilonewton meter, but my C now is 60 mm, and that also divided by 9.8 times 10 to the minus 6, and my normal stress, bending stress at point B is 91.7 megapascal. Okay, so that's the answer of how we want to go about finding the bending stress for beam. Talk to you guys later. Bye bye.